Assalamualaikum and a very good afternoon. First of all, I would like to introduce my team member. We are from Group 10. My name is Nur Afifah binti Roslan. There is Ifa Azli, Abdul Radi, Najib Ikram, and also Wan Amni. Introduction. Integrated IC design is a process of interconnection circuit elements to perform a specific desired function. So, the objective of our mini project is to design a minimum 12 transistor to obtain simulation waveform and able to pass design through check DRC. So, today we would like to in MP01, each of our teams need to design their own design, which is we need to include 12 transistor. After that, in MP02, we need to discuss and make decisions which design we want to choose as our final mini project. So we choose using our SMART and SWOT analysis. SMART analysis should look into 5 perspectives, which is specific, measurable, attainable, relevant, and time-based. For SWOT analysis, we look for 4 perspectives, which is strengths, weakness, opportunities, and threat. So, after we done the SMART and SWOT analysis, our final decision is we choose one Omni design. This is because one Omni design is less number input and also less power consumption, and also it also satisfied the SMART and SWOT analysis. So our boolean, this is our boolean. Our boolean is y bar equal to a bar, b, and c bar. So we invert using inverter. So therefore we get this y equal to a bar, b, and c bar. Based that Boolean equation, we get these two tables. So this is our final schematic diagram, and also this is our final Euler parts, and also our final stick diagram. Okay, that's all from me. I pass the next presentation to Wan Amni.
So for my part, we continue with methodology. For the first thing we do, we sketch our schematic diagram on the paper. We sketch our schematic at the VMware workstation. After that, we check our waveform. Is this obtained or not? If yes, we go through our layout, and after that we check DRC and LVS. So for this mini project, we interrupt the engineering design procedure. For the first is define the problem, conduct research, brainstorm and conceptualize, create a prototype, select and finalize, product analysis, improve product design, and what make the design process easier. So for the schematic diagram, we continue with Radi.
Thank you, Mr. Wan Amni, for the explanation about the P and the methodology part. So now I will explain about the schematic drawing using the VMware workstation. So basically, like we all can see, there is 12 transistors in our mini project. So basically 6 from the 12 transistor is the PMOS transistor, and another 6 is the NMOS transistor. So we also have 3 input, which is A, B, and C, and another one output, which is Y. So there is 2 parts, which is pull-up network and pull-down network. So the pull-up network is obtained from the PMOS part, and the pull-down network is obtained from the NMOS part. So next we will look for the test bench. So we get the test bench from the schematic drawing area. So we generate the symbol from the schematic drawing and we get this symbol. So This symbol we will attach to the PWL, and we set the PWL according to the row table we get earlier. Besides that, we also connect the PWL, all the PWL to the ground. We also have for about 5 volt for generate the voltage to the schematic drawing. Next, I will pass back to Wan Amim to explain about the waveform for more details.
So as you can see, the waveform is similar with our truth table, and the output become 0 is because the pull-up network drive output to VDD. So in this CMOS integrate, our pull-out network is PMOS. PMOS is an active low. Automatically, our CMOS structure will become active load. That because why we get output 0. So for the layout, we continue with Najib.
Next is layout part. The green color represent active. The red color is for polysilicon. GND and VDD are blue color. The purple color is stand for metal 2. The length parameter from VDD to GND is 40 lambda. The length from active PMOS to active NMOS is 12 lambda. The active length is 3 lambda. The length from active to excessive PMOS is 2 lambda. The width at polysilicon is 2 lambda. The width metal and metal 2 is 4 lambda. And the last one is the gap from metal 1 to metal 2 is 3 lambda. Next, I will pass to the next team member, Yusifa, to continue the presentation.
Okay, hi, my name is Nurifa. So I'm going to continue for the layout in the VMware. The first part of the layout is redesigning the VDD. First, I am inserting the metal connector. Second is active. The third layer is N+, and the last one is N well. I am adjusting the position to make it center, and then put metal above the layer that I am making just now, and the VDD is done. Next, the polymer. There is 7 poly in this design. Poly. Also, we insert the active layer N+, and P well for NMOS, which is pull down network. For PMOS, I am inserting P+ and N well, which is pull up network. I am checking the length to make it easier on the RC part. The length is stated by Najib just now. After connect all the metal 1 to their own poly as explained before on the layout sketching, I am putting metal 2 using the different metal, which is the purple one. Next, setting up the input is for poly. There is 3 input, which is A, B and C. A and C is invert using the inverter. Ground. Ground is same as VDD, but we change N+ to P+ and N well to P well. Final part, I am adjusting all the layer to be same as the layout sketching to make sure there is no error on the designing. And this is the final part on the layout design before running the DRC rule check. Mr. Radi, you can explain for the design rule check.
Thank you, Ms. Ifa, for the outstanding explanation of the option. So now I will explain about the design rule checks. So at our first step, we obtain about 120 errors from the DRC check, design rule check. So after we figure out one by one for the error, we find out that the error is coming from the size of the metal one, which is the blue color one. So the requirement is about 4 lambda to draw the metal one connection. So in our design, layout design, we only use 2 lambda for the metal connection. So we change it from 2 lambda to 4 lambda for all the metal one connection. And then we check another error, which is the PMOS and NMOS active foreground and VDD. The sizing also is not the same as requirement. So we change the size to become bigger from the old one, which is the requirement for the design check. Next is the distance between the poly and active NMOS and active PMOS. So after we check, there is a slight short from the original one, so we change it to become a longer version. So next is the final attempt, which is we obtain zero error, which is there is no error after we make a correction for the layout version. So as we can see, it's become more bigger and more wider compared to the old one. Ms. Ifa, I think you can explain about the layout versus schematic, which is LVS.
Okay, thank you, Mr. Radi. Okay, first, this is the setup for the layout versus schematic in our project. Okay, unfortunately, we're facing an error on LVS part, which is it says that all the port is unattached in a cell. After identify all the error, we try to troubleshoot back our design by checking the schematic. But the output of the waveform is correct based on the truth table. Next, we fix the DRC part. The rule of design in VMware is that the DRC is successful, meaning that there is no error for the DRC part. But after we rerun back the LVS, we still got the same error. And after identify it, I think the error is because of the layout not detect the current. So there is no current transfer to the poly. As you can see here, for the VDD and poly, there is a highlight, which means there is no current flow to make the layout working. Because of we're running out of the time, we can solve the problem. Maybe if we have another extra 3 to 5 days, we can identify the correct error and troubleshoot the layout instantly. I think that's all for the layout versus schematic part. Mr. Najib, you can conclude this presentation.
Thank you, Ms. Ifa. So, as for conclusion, several types of techniques has been used to create this integrated circuit. The circuit also has been analyzed by using MPS and DRC technique to validate the specific design, having this project completely successful. A way forward for this project is to use multifunctional transistors. These transistors can form as both gate logic and input switches. The other suggestion is to select the suitable IC design software. Pick an IC design software that is compatible with VMware. With some visualization, some tools could perform better than others. That's all from us, Team 10. Hope you guys enjoy our presentation. Don't forget to like, share, and comment in our video. Thank you.